Um, Hello, everybody. If you're able to, hear me, just type something in the message bar where I said hi, uh, so that I can start with my presentation. Okay. We'll wait for say 5 minutes. Uh, I'll give you guys some time to, just get set up your microphones and whatnot. Uh, Once the time's over, I'll start away with the PPT. Okay? I forgot to assign slide. Vinal. Vinal. There might be a little lag between what I say and what might appear on the screen, and when I type, there might be a little delay. But I think it might be noticeable. But I'll try my level best so that to give you guys a high bandwidth thing. I did check the ultra low latency option so that latency does not become an issue. But still. Uh, I'm just putting it out there. One more thing, if there is any disturbance in the audio, please let me know. I'll turn off my laptop fans and the fan in my room as well, so that doesn't become a problem. Uh, okay, I'll start my presentation now. Uh, Sandeep, is it okay? Shall I start, or do we have to wait for somebody else to join the stream? Okay, okay, Sandeep. Chalo, we'll start. Uh, Okay, our topic for today is cloud deployment, meaning how would you deploy applications to the cloud? And when I say cloud applications, for the uh, purpose of this discussion, at least, I will limit myself to web servers. Okay, uh, that's what I mean by application deployment towards the cloud. So my focus would be on how to deploy applications onto specifically AWS, because that was asked of me that that you guys would be working on AWS, and so okay, I'll be covering that, and specifically I'll be covering two aspects of that. So AWS has two kinds of services that you can use. One is a set of managed services, meaning that everything in that service will be managed by AWS, and you'll have to pay a price for their management service as well. And the other is you manage your deployment yourself. So I'll be talking about both of those things during the course of this webinar, and also I'll give you a hands-on demo as how can you do that. Personally, I prefer rolling out the web deployment yourself because it gives you a granular control and it's much more cheaper to do it that way. But if you still want to try out the AWS services, I highly encourage you to go and check out those services as well. Personally, I don't have much experience with dealing with managed services, but you're more than welcome to check them out. So I'll be showing you how to deploy your applications on regular machines onto the cloud. Okay, enough chit chat. Let's get into it. So let's start with the definition. What is cloud? Cloud refers to servers that are accessed over the internet and softwares and databases that run on servers. Cloud servers are located in data centers all across the world, and by using cloud computing, users and companies don't have to manage physical servers themselves or run software applications on their own machine. So that becomes a major part of what makes cloud the cloud. It's not just a single bunch of machines sitting in an office's IT department. So instead of that, they have put all the machines into the data centers instead, and nobody these days is actually preferring physical infrastructure. All they care about is how they get their compute and they get their networking capabilities. That's all. If any cloud provider is able to meet those demands, they can obviously shift over to cloud services. And speak about that, one interesting point that I would like to add is cost-wise, you get significant savings when you talk in terms of billions of dollars for big corporations whose compute needs are, relatively very huge. So if they had they sorry, if they would have an IT department in place that would be, uh, responsible for assembling the servers and putting up the network, right? Writing up the correct config files, network policies, and whatnot. So instead of doing that, you put all that burden onto cloud companies that will do it for you, and they will do it for a fraction of cost. That is the major advantage that I see with cloud, and many of the organizations do as well. So coming to a history of deployment, so as I said previously, people used to have physical servers installed in their offices. That they used to have that, like we have at MSIT, we do have our own infrastructure. We have our own mail server and web server and dev server and all that setup, because since our needs are relatively less and we can afford the infrastructure, so people go for physical infrastructure. And the other tier of deployment was using virtual machines. So I'm assuming that you guys are familiar with virtual machines. So I'm assuming that you guys are proficient in virtual machines. Uh, okay, cool. So virtual machines is, we'll look at what VMs are in the next slide. hmm then virtual machines is basically, yeah, we'll jump one slide ahead and we'll come back to this slide. So virtual machines typically look like this. You have your physical infrastructure, meaning the physical server rack on which you have your processor, motherboard, and all the physical networking, I/O, and drives and all sorts of stuff. And on top of that, you have something called a hypervisor. Hypervisor is typically the software that forms the bridge between the guest operating system and the virtual machine. Usually that sits in between the two. Usually it's something like VirtualBox or VMware, right? And on top of that, you have virtual machines, and each have some sort of applications running on them. The advantages of using one big advantage of using virtual machine is you can efficiently use your hardware, pack it into manageable VMs, and run applications on top of them, and that becomes highly lucrative. You get a very granular separation between our applications, but the problem is VMs are a little bit slow. They are difficult to scale, because if you want to deploy a new application D in this setup, again you will have to spin up a machine. You have to boot up the OS onto that. You have to put the config on that and install your applications on top of that. Then connect it to the network and all sorts of things. So, and that also puts a lot of overhead on your hypervisor and your infrastructure as well, though it provides a granular level of abstraction and separation. So that's the overhead that you have to pay if you are doing away with virtual machines, right? Uh, so that was VMs, and the latest one is containers. So I'll tell you what containers are in the coming slides, because I'd have to give you a little bit intro about Linux's some of the core components of Linux. Uh, I'll talk about containers in the next upcoming slide. But containers are the order of the day. So you can containers are very lightweight, so you can ship containers very easily into production. You can containerize your code very easily, and you can move around your code. And the main advantage of containers is that you are not limited by the capability of the uh, guest operating system on which on the operating system that you are running on. So this infrastructure has a host operating system, right? So you have Windows on your machine, and you have VirtualBox, and you are running Ubuntu on VirtualBox. Suppose that is the case. So your physical infrastructure has a host operating system, right? So if it's not compatible, and if it does not have the capability to run, say, any applications in your VM, that becomes a very big problem. Same goes the other way as well. For suppose if your guest operating system does not have the capabilities to run your application, one big disclaimer: this capabilities is only in case of platform dependent applications, like say a Python script or a JS script, since they are not platform independent things. So that's for that. So in such cases, containers will be your best friends in doing that. Uh, Also, if you have any doubts, uh, uh, please feel free to drop a message in the live chat. I'll check. I'll be checking it periodically. Please feel free to interrupt. And even after the live stream, I'll hold a Q&A session for probably 10-15 minutes. Don't worry, I'll not go over time. I'll try to fit in, complete before time, and try to fit in the Q&A session for 10 to 15 minutes in the given time frame of 1 hour. Got it? Chalo, let's move on with our thing. So, how ways to deploy an application in cloud, as particularly AWS. So, as I said earlier, for the context of this talk, let us assume an application means web server. So here are the more or less the popular ways of doing it. One is putting it on an virtual machine inside AWS and running it. So this is a self-managed solution. AWS only just provides the VM to you. You'll have to install the software and whatnot. And the other is Elastic Beanstalk. So Elastic Beanstalk is a language specific runtime for applications on AWS. So you have a Python application or a Node application or a Ruby application. So they have a very large collection of programming languages that they support for web applications. So all you have to do is put your code onto Beanstalk, and it will take care of the hosting, provisioning, the servers and whatnot. This is a managed service and it will cost you more. Similarly, with ECS as well, ECS stands for Elastic Container Service. So you containerize your application and give that image. You have to put this image on Amazon's own repository of images, and it then Amazon will run that container for you. Again, this is the managed service. And last but not the least is my personal favorite, Kubernetes. It has been a very good technology. It has been around since late 2014. It's a project sponsored by the Cloud Native Compute Foundation, CNCF. It was actually an internal product at Google called Borg. So it was transformed into a project called Omega, and then it was transformed into Kubernetes, which we are using. That Google open source that project. So they have been dealing with containers since 2003. So uh, Google is kind of an expert when it comes to containerized technologies, and they have their own container engine as well. You have in GCP, you have container runtimes as well, which run on Docker. So yeah, so these are the ways to deploy an application on cloud. Don't worry, I'll cover each of these ways on deploying. I'll show you a hands-on demo as well. Okay. Okay. Moving on. Yeah, we talked about this, right? How VMs work. So, what is Docker? Okay, we have to start with this fundamental questions and move on. So, Docker is a containerization technology that helps you containerize your application and run. Lets you run it on other machines. So we have looked at this one, right? So you have a hypervisor that will actually, talk with the host operating system that is present on the infrastructure and execute code. So the flow goes something like this: the virtual machine has guest operating system. So this app wants to execute a command, so that goes to the guest operating system, that goes to the hypervisor, uh, that will go to the actual host operating system's kernel, that will execute the tasks. So you have this large amount of overhead going on and forth, and you need a lot of memory in order to run very large number of instances of these virtual machines. So what containerization is, it is a technology that makes use of two particular Linux core components called namespaces and C groups. Okay, these are two core competencies that have been in Linux for a very long time. So, making use of these two concepts, you package your code into a single instance called an image, and that image, while it is running, it's called a container. When it's not running, it's called an image, and when it runs, it's called an image. So, what is namespace? You might ask. So namespaces are a feature of Linux that partitions kernel resources says that one set of processes, one set of resources, while another set of processes sees a different set of resources. So think of namespaces as think of namespaces as an abstraction over the Linux operating system. So you might assume this. Say you have your computer, right? So you might be logging in as with your username. Say you wanted to add another user to your computer. Linux lets you do that, and even Windows lets you do that for the matter of fact. So say now assume that you and the other person, you have created a new account for the another person to log in onto your machine. So both your files are kept separately from each other, right? You make the changes in your part of your file system. He makes changes, he or she makes their changes in their part of the operating system, right? So think of namespaces like that. So it provides you with a sandbox type of architecture, meaning that whatever you do, whatever you make changes, whatever type of processes that you run on namespaces will underlyingly use the Linux kernel to make that call to the physical infrastructure, but they are logically separated from each other. That's what namespaces are. Similarly, C groups work in tandem with namespaces that isolates the resource usage of a collection of processes, right? So this is like a new user account for your operating system, and C group is basically a limit over the resource usage of those particular set of processes that you are running on namespaces. Since we don't have a lot of time, I'll not go in depth to namespaces and C groups. You are more than welcome to do your own research, and if you have any doubts regarding that this particular topics, if you need further explanation, feel free to talk to me or write to me. I'll get back to you. So uh, those two are the key features that drive the containerization technology. So containers basically contain images that you run. You run a binary or a command in that container, in that image, on that image to make it a container. So they contain a running process. So in Docker is one type of containerization technology. You have other types of softwares that do containerization like RKT and Cryo. There are many types of things. You can explore them yourself. So Docker is one such thing. So Docker runs a process called a Docker daemon. So it's a process that runs on your machine, and that will create its own namespace in C groups, and that will let you run your containers on that machine. So like GitHub, you push. I assume that all of you push your code to GitHub, right? Similarly, for Docker images, you have Docker Hub. It is a repository. Uh, it is a repository that contains images of your applications. You can create a free account on Docker Hub, and you can uh, push your images. There is no limit on how many images you can push. So one key point is Docker uses something called as overlay FS. Uh, just keep that in mind. It's like layers of cloth, one over the other. So whatever we'll see, I'll show you a Docker file in one of the upcoming slides. So what it does essentially does is, instead of storing the entire code base that you have, all that does is it takes a base layer and it builds on top of that, keeps on building until you get a stack. So in case if you have two layers in that file system that have no similar differences, so that layer actually gets excluded from the your image building process. So it only stores the diff, like your git stores only the difference of code that you push, right? It doesn't actually store, it stores the file, but it also stores the changes in the file, right? Basically git stores the diff. Similarly, Docker also uses a similar concept called overlay fs that stores data in layers. And Docker has its own way of interfacing with the host operating system as well. For networking, you have container networking interface. For storage, you have container storage interface as well, CNI and CSI. So they both take care of the volumes, volume meaning the storage of the container runtime, and the networking of the runtime as well. Okay, so this is how Docker would look like. So you have your physical infrastructure, you have a host operating system on top of that, you have a Docker daemon, and you have containerized applications. So there is no bloated big VMs, and there is no guest operating system for each of the VMs, and you have to, this has to talk with this, that has to talk with this, and then it has to talk with this. Sorry, we have done away with one layer at least. So all of these are containers running on the infrastructure physical host machine, and Docker daemon actually controls each of these machines, and whatever commands they want to execute, they can directly execute on top of the host operating system. So the host operating system will share the kernel with the Docker daemon, so they can directly execute. There is no need for a hypervisor to orchestrate your virtual machines and translate the guest operating system's kernel call, system calls into the host operating ones, and give it to the host kernel to execute on the physical infrastructure. So that is a big advantage of uh, uh, Docker. Okay, I'll show you a small demo now on how to run Docker on EC2 machine. So I'm assuming that you guys know what AWS is, and what AWS EC2 is. Hello, hello, hello. Am I audible? Okay, there was a little delay. I thought that my stream had cut out. Okay, fine. So uh, guys and girls who know what EC2 is, explain it to your friends. Since we are running out of time, I would like to speed this up. So EC2 is basically a VM that AWS will provide, that you can run software on. Uh, just hold on a sec. Uh, Okay, it will take 1 or 2 minutes to for the VM to spin up. Till then, I'll take you through some of the gists that I've created. These are openly available. You can go check them out on my profile. So this is what a Docker file would look like. So you start with a from command. Okay, and one more thing I forgot to mention. All the demos that I'm giving will be for a React app, since your web programming was on React, I thought that it will be good teaching opportunity for me to teach you guys about how to containerize your React applications. So a typical Docker file would look like this. So it starts with a from command, and you can observe that I've written a node image. I'm using a node image. So this from command basically is followed by a base image. Base image would be an image that you would use to build your software on top of it, right? So if you are using React.js, the installer would be npm or npx, right? For that, that's why I went with the node js image. So let me just quickly go to my Docker hub and I'll show you. Right. So if you are using, say, a Python image, if you are using a Flask web server, you would pull a Python image. So that I would be replacing this from followed by Python colon the version of the Python that you want. Or if you are, say, running a Java web server, you can write web server with Java. So something, yeah, OpenJDK. I'll be using OpenJDK. I'll pull OpenJDK and run Spring on top of that. If you are using a servlet, I'll pull the Tomcat image. So base image will be based on base image will be based on top of sorry, base image is a technology, or you can say or base image is a thing that you specify based on the type of programming language or technology you are using. So base image, there are a lot of images that you can use as base image. So at least for this discussion, let's limit ourselves to using the understanding base images as uh, the environment that is determined by the type of programming language that you are using. Okay, so this is a Docker file. You will put this Docker file in your source folder, right? And you will copy certain files, right? Package.json, package log.json. You'll be copying these files and you'll be installing your dependencies on top of that, and that's it. Once you see how small it is, with just these many lines of code, you can containerize your application. That's it. And you containerize that, and there is a git ignore file as well. So you can write a git ignore file to ignore these particular files uh, while building your image. Actually, I wanted to show you the process of building an image as well, but my for some reason there was an issue with my VM. I couldn't get it to comply with my streaming thing. That's why I've already built some images for you guys. Uh, at least I'll show you how to deploy them. Okay, so this is a React app that Hello React app that I wrote yesterday. Basically, it's nothing. It's just creation of a React app. I'm sure you guys have done significant work on React. All right, let us check on the VM. Okay, the VM is running. Guys, I'll be using my command prompt. Is my command prompt if oh, my command prompt will not be visible. Okay, I have given you the list of commands here to build that image, and I'll share you the presentation as well. Uh, for now, at least, I think my command prompt will not be visible to you because of my this recording software that I'm using. But you can find the commands that I'm typing on the presentation. I'll share you guys the presentation after this thing is over. But bear with me for a few seconds. I'll show you. I wanted to show this on hands-on, but there are certain limitations for me. So quickly, I'll just SSH into the machine that I have. Yeah, so I've SSHed into my machine. So actually, this is the process that you need to follow. What you can do is you can write that Docker file similarly for your application, then push it to GitHub, then clone that repository onto your EC2 machine, then build your image there and push it to your repository. But personally, if you have your own Linux virtual box, that will be a better thing to do instead of unnecessarily wasting compute on AWS. What you can do is you can, you know, put up a virtual box with Ubuntu or Manjaro or any Linux distro that you like and install Docker. For installing Docker, all you need is this command right here: curl minus fssl get.docker.com, pipe it to sh. That's it. That will install Docker on your machine. There is no complicated procedure and all. There is nothing like that for Docker. It's very simple. Curl minus fssl get.docker.com, pipe it to sh. That's it. Okay. Uh, just a minute, guys. The I'm installing Docker onto the VM. Might take a couple of minutes. You might not be able to see my command prompt. Let me just see if I can fix it. Okay, now are you guys able to see my command prompt? Uh, can you are you able to see my command prompt? Okay, that's good. I fixed it. We'll get back to the EC2 instance later. Now you can see my command prompt, right? Okay, so I ran these two commands. That's all. I ran sudo apt-get update. Then I installed curl minus fssl get.docker.com. Uh, okay, now I've made it a little big so that it's legible. Yeah, yeah, I just did. Yes, sir, I did that. I increased the size on the command prompt. I increased the size on the command prompt. Okay, so now as I've mentioned earlier, I already containerized my image, so I have it here on my Docker hub. So all you need to do is type in. That's it. Your it Docker hub is similar to GitHub. The way you have github.com slash your username slash your repository name. Similarly, you have your username slash your image name. So that's how it is going to be. and you can only pull images that are public. Like in Docker Hub shares many similarities with GitHub, so that's why I keep comparing it to GitHub, because it is something you guys have been using and many of people know. Docker. So if this image is public, you can pull it. Otherwise, you cannot pull the image. Got it? Okay, let's pull my image. Just waiting for it to complete. Will take just a few seconds. Okay, I've pulled my image. So, by the way, if you want to refer to any CLI commands that I'm using, you can check out Docker docs. They have the whole list of commands. Or let me just check. Okay, you can go to man Docker. I always keep forgetting that you can use man pages. You can type man Docker and you can see all the commands. So, in order to let's see the image that I've pulled, is it here or not? So yeah, my image is here. This is the tag that I have. I created it yesterday, so 24 hours. So this is the size of my image. So let's try running it. By the way, I'll explain the command I'm typing in just a bit. Okay. So Docker run hyphen hyphen name is the name that you want to give to the running container. Minus it is provide this container with an interactive terminal. I is interactive, T is a teletype terminal, TTYL. So that, and minus P is port. I am asking it to bind 3000 port of the Docker host to the 2000 3000 port of the container that I'm running. So this is the name of the image that I'm running, SPRX7767 React, and I'm specifying the command I want to run on that container. So like you say, node space server.js, or if it's Python space server.py, something like that. So in my case, it is npm start. Let's try running it. That's what it is. Okay. So since I've given this minus d output, what it does is it will not show me any output. Otherwise, it will automatically go into the uh, go on splitting out the logs that this container is generating onto the standard output. I purposefully mentioned this hyphen d tag so that it doesn't happen and our screen doesn't get cluttered. Let's see if our container is running. In order to check that, I type in sudo docker ps minus a. Okay, see, so it says that it's running, and it is binded to localhost colon 3000. It's not localhost actually, it's the IP that the Docker container has, container, and port 3000, and the name of the thing is React. Let's go to the browser and check it out. Okay, we are in the browser. Let's go to the DNS, and you have to go to 3000. Okay, right? You can see the React app, right? So I thought that there might be a security group problem with AWS. So that is how this is how you would this is how you would react. Sorry, you would deploy a React application on Docker on top of EC2 instance on AWS. But I have to tell you that this is kind of a frugal way. In Hindi, they call it jugaad. I don't know the Telugu word for that. So it's a frugal way to deploy an application onto the machine. But if you have limited amount of resources and you want to easily ship your application into production, containerization is the way to go. And when I say this method, I'm not talking about containerization on the whole, but uh, how the way I deployed application by installing Docker and then putting on that. It's a little bit frugal, and it's only for the people who who want to get down and manage the application yourself. But if you want somebody else to manage your application and you want to just worry about deploying the don't worry about the deploying and focus more on development. There is one more solution for that as well. It's called ECS, Elastic Container Service on Amazon. You can check it out with this link. As I mentioned earlier, it's a managed service and it will cost you a little bit more. So this is how ECS would work. So I have mentioned Docker Hub, right? So similarly, Amazon has their own container registry called ECR, Amazon Elastic Container Registry, and you can actually configure your Docker daemon to push code to this registry instead of Docker. So only the people who have the keys to your API access keys that Docker Hub has generated for you will be able to view and make changes to the images. So that will contain all your things, your container image that will put your container image on EC2 instances and containers on Fargate and manage those contain. All these things that I've mentioned will be encapsulated in one container service. So you this is all abstracted away from you. But the thing is, you'll have to pay for EC2, you have to pay for Fargate, and you also have to pay for the Elastic Container Service. You have to pay for the container registry as well. So all these things come at a cost. But if you are like me and you want to have a handle on things yourself, you are more than welcome to install Docker on a couple of VMs and actually deploy your application on top of that, right? So that was Docker. And before I jump into Kubernetes and conclude my talk, uh, uh, are there any questions at this point? I'm more than happy to answer. Otherwise, I'll move on with my talk. Okay, fine. I guess there are any questions at this point. Maybe after the talk, maybe some people would like to talk to me. Fine. So, since I have shown you how to deploy one container, right? But if you have to deploy n containers to manage your traffic to your web server and put them behind a load balancer or whatnot, it becomes very difficult for you to keep on running that Docker run command yourself and maintaining the storage and maintaining the networking for that. And so it becomes a very difficult task to keep track of doing that. Actually, there is one container orchestration technology called Docker Swarm that is developed by Docker people themselves. But people usually prefer something other than Swarm like Kubernetes because it is much more robust, much more secure, and it gives you a very good granular control over you know how things are done about. So, without further ado, let's jump into Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. The key here is containerized applications. You can only deploy applications on Kubernetes if they are in the form of a Docker image. So you can't take your just your code and run it on Kubernetes. It has to be containerized, and Kubernetes will use Docker as its runtime. Although Kubernetes is very flexible, you can have other runtimes, and there is a lot of customization in Kubernetes. You can actually uh, disassemble Kubernetes and make it configure it in such a way that it will use different technologies and different software for different purposes. Like Kubernetes networking is a very huge ocean. You have different things like Flannel, Calico, and there are other technologies that will actually manage just the networking in a Kubernetes environment. Similarly, for storage, you have something like Ceph and Ansible. So using Ceph, you can control the storage inside a Kubernetes cluster, right? So similarly, the runtime, Docker, Cryo, Rocket, RKT, you have different container runtimes. So it provides you with a very fine-grained control over things that you specifically want. For suppose if you want Kubernetes to use a particular type of networking, a particular type of storage management solution, a particular type of container runtime, you can obviously do that. And the good thing with containerization is there is something called OCI, Open. I forgot the I forgot the acronym for that. So Open Container Initiative, right? So this Open Container Initiative makes sure that irrespective of the runtime that you are using to run your container, all these adhere to a particular standard. So you can take a Docker image and still run it on other runtimes. Similarly, vice versa. You can take other images that are built on different runtimes and run it on Docker as well. So that's the good thing about Kubernetes, is that since it is very flexible on what type of container runtime you are using, it is very easy to configure and manage cluster. So yeah, I spoke about container runtime, I spoke about network storage interface. So there are these things called objects in Kubernetes, which you actually use to deploy your application onto a Kubernetes cluster. The smallest of these objects is called a pod. So that pod becomes the basis for all the other objects that you want to run on Kubernetes. So anything you do or deploy on Kubernetes has to be a pod. So a pod is basically the smallest unit in Kubernetes, and it can run one or more than one containers inside it, right? So I know it is a little bit abstract at this point, but given the timeline, I think I'll stick with the abstract definitions of what things are, and maybe I can clarify some of the other things uh, privately, or maybe another session if we have you guys can spare the time. So there are pods in Kubernetes, and you can group these pods together, and you can have many pods of similar kind, and you can expose these pods to the internet, and you can network these pods together, and you can do all sorts of crazy things with pods, right? So pod is the basic abstraction that we are provided with, that you can work with in Kubernetes. And in order, how do you create a pod? So I said pod basically contains one or more containers within itself, and uh, that they will run the containers inside themselves, right? So in order to there has to be a way for you to interact with Kubernetes, right? Like the way for you to interact with Docker is with using a Docker file, right? Similarly, the way you interact with Kubernetes is via kubectl. Kubectl is a command line tool that is written by CNCF people, Kubernetes people. It's short for Kube Command Line Tool. Some people call it kubectl. Personally, I call it kubectl. So kubectl is the CLI tool, and the uh, this is the way you can interact with the Kubernetes cluster. And the other way is to write a manifest file either in YAML or JSON. YAML is a markup language like your HTML, and JSON, I'm sure most of you guys are familiar. So the de facto language for interacting with the Kubernetes cluster is YAML for creating objects and whatnot. So YAML, people usually write manifests in YAML, and yeah, you can use YAML files to generate objects on Kubernetes. And one big plus with Kubernetes is integration with cloud, right? So Kubernetes has this dual behavior where if you want to run Kubernetes locally, it will behave in a certain way using your resources. But say if you were to deploy Kubernetes on cloud, it will automatically integrate itself with the cloud resources, and it's also cloud agnostic, meaning that you can deploy it on AWS, you can deploy it on Azure, you can deploy it on DigitalOcean, you can deploy it on Linode, irrespective of the cloud, irrespective of the operating system. So it is platform agnostic, and it is cloud agnostic as well. You can deploy it on any cloud. One caveat is you might not get the latest version of Kubernetes. You might get one or two revisions behind, except for GCE. Since it is a Google project, GCE provides you with the latest version of Kubernetes. So that's what Kubernetes is. I'll not discuss any further Kubernetes objects. I'll just go into the architecture and show you how I would deploy a Kubernetes cluster, how easy it is to bootstrap a Kubernetes cluster. So yeah, this is the architecture of Kubernetes. Basically, the thing that you see on the left side, I'm hovering my cursor on, is called a master. So and master will be connected to nodes. So these three things are nodes, right? So you have one master and you have three nodes. So there is no hard limit on number of masters. You can have any number of masters, but the thing is you have to have one master node and one worker node compulsory. That is the only thing. Instead of that, you can have multiple masters. You can have multiple as many number of nodes as you can. So this is the control plane. The control plane controls the entire cluster. Some of the key components are Kube API server. So I talked about kubectl, right? The command line tool that you can use to interact with Kubernetes. So when you type a kubectl command, that actually goes and hits this Kube API server, and that will actually give you the response. Uh, so that's the job of Kube API server, and it's also responsible for talking with all these processes called kubelets that sit inside each of the Kubernetes nodes. And there is kube proxy. Kube proxy is basically Kubernetes' internal networking solution that sits on each node, and this proxy will actually is responsible for taking the request and sending it to Kube API server from the kubelet, right? So the request goes from kubelet to kube proxy to kube server. That way it can maintain that abstraction over this. And kube scheduler is basically a scheduler. It will decide where the pods can be placed on each nodes. So that's a whole different ball game. And in case your cluster crashes, right, you want to bring it up. That's the job of HCD. HCD is a key value store that will store the state of the cluster. What are the pods running? What is the IP of each pod? What is the IP of each node that is running? What pods are scheduled where? What images they are using? All the metadata and the data of the Kube API server is stored in HCD. And Kube Controller Manager is responsible for controlling all of these things, replication factors, and how your server is set up. All the config is stored in Kube Controller Manager. And you have Cloud Controller Manager. Like I said, right, it is cloud agnostic. This component is only present if you are deploying Kubernetes on cloud. If you have if you are deploying it on your own machine, this component is actually omitted, and you have rest of these components. And by the way, I forgot to mention, if you guys want to check out Kubernetes on your own machine, um, I suggest Minikube. Minikube is the name of the software that you have to run. It will only run on Linux. It runs on Windows, but it is not that great. Minikube is the software that you want. You can install that on Linux. Okay. So now to end my talk, I'll show you how easy it is to bootstrap a cluster on AWS and deploy the same React app that we have written here, right? I'll deploy the same React app on a Kubernetes cluster. Just bear with me for 5 more minutes and I'll complete the talk, right? You might have noticed that I have for the previous Docker thing I used Amazon. I used Ubuntu as my operating system, but now I'm switching over to Amazon Linux. That's because it's a little bit easier for me to since Amazon Linux comes with some of the you know it comes pre-installed with AWS CLI, and it's a little bit easier for me to interact with AWS's objects as well. Just bear with me for another 5 to 10 minutes, guys. I'll be done with my thing. Uh, So I've attached a IAM role to this machine called COPS role. Basically, IAM stands for Identity and Access Management. It is AWS's way of ensuring that only authorized people and authorized users have access to what the AWS resources, right? Just give me a second. I'll just have to copy something over. Right, I'll switch to my different window. Right. I hope you are able to see my command prompt. Yeah. So this is a shell script that I wrote. Basically, it is a bunch of statements that will install a software called COPS. COPS is short for Kubernetes operation. So basically, what it does is it will bootstrap the cluster. It will create automatically the machines one master, two nodes, or something like that. One master, two nodes. Yeah, one master, two nodes, and it will provision all the machines, install all the necessary software in each of these nodes, and then it will bootstrap the cluster and in the end show me the output, right? So Yeah, just be patient with me for another 2 more minutes. I'll bootstrap the cluster, show you that, and in my thing. So I'm creating an S3 bucket that will actually store the state of the cluster. So anytime you want to, restore this cluster, stop and start this cluster, that state will be stored in S3. All this config. Uh, yeah, it's a variable. It's environment variable. It needs an environment variable. That's why I questioned what you said. Right. See, so what happens is it will provision all the resources that is necessary for this AWS from the AWS side, right? See, all these things. The security group, it will create a key. The security groups, subnets, mostly security groups, the VPC, CIDR, all the network things, all that is necessary from AWS, all those resources will be bootstrapped by this cops thing. So all I type is this one command, cops update cluster, name of my cluster, and yes. Right. Yeah, while this is executing, yeah, the cluster is executing. Just give it a few minutes. Uh, so yeah, just let me bring up something. Yeah, see this. Let's look at this highlighted command that I'm highlighting, right? Cops create cluster, name of the cluster, zones, which in which zone you want to create your cluster, master size. So this is the size of the master. I've mentioned T3 medium, and this is node size T3 medium. If you want to try it out, you can actually try this out. If you don't want to pay money for that, what you can do is instead of T3 medium here, both the sides, what you can do is you can change it to T2 dot micro, right? Since T2 dot micro is free, you won't be charged for anything. Got it? By the using T2 micro, so that the networking isn't that good. That's why I prefer using T3 medium. But you can still use T2 dot micro to build a Kubernetes cluster and deploy applications on that. Yeah, while this does, let's switch over to the